Data Masters is the go-to place for data enthusiasts. We speak with data leaders from around the world about data, analytics, and the emerging technologies and techniques data-savvy organizations are tapping into to gain a competitive advantage. Our experts also share their opinions and perspectives about the hyped and overhyped industry trends we may all be geeking out over. Join the Data Masters podcast with your host, Anthony Dayton, Data Products General Manager at Tamr.
Welcome to another episode of Data Masters. Today we have the privilege of hosting an exceptional guest, Dr. Dana Van Aken, the brilliant co-founder and CTO of OtterTune. OtterTune is a database optimization tool created by a team of database researchers at Carnegie Mellon University. The company envisions a future where developers can deploy and administer cloud databases without needing to be database management experts. OtterTune's customers include Booking.com, Nordigen, and Postscript, along with prestigious institutions such as Carnegie Mellon University. Before embarking on the OtterTune journey, Dr. Dana Van Aken was a PhD student at Carnegie Mellon University and also undertook notable research internships at Microsoft and Google. With a wealth of knowledge and experience in the field of computer science, Dana brings a unique perspective to the realm of data optimization. We're thrilled to have you here with us, Dana. Welcome to the show.
Great. Thanks so much for having me. Happy to be here.
So you have a great sort of an impressive background in data and technology. You've been working in this space for many years. Maybe you could share a little bit about your personal journey and also how that personal journey intersects with OtterTune, which obviously you're a founder of, so it's a direct link. So maybe share a little bit about that journey.
Absolutely. Interestingly, OtterTune started out as an academic research project. So my journey sort of with OtterTune started around 2014. I had applied to a number of PhD programs, and one of the programs that was accepted into was Carnegie Mellon University's computer science department. So that's when I met professor at Carnegie Mellon University and also OtterTune CEO and co-founder, Andy Pavlo, who is, well known in the database space. And he, after speaking, he had recently had this, great vision about database tuning using machine learning, and had recently submitted a proposal, and I was trying to get me was trying to get me to join him as a PhD student, and I decided to join him in 2014. And that's around the time where we began the work on OtterTune, the academic research project. So the goal of OtterTune, in the research project, was to do automatic database configuration tuning using machine learning. So we, worked on this for a few years. We published our first paper at a SIGMOD conference, which is an academic conference, in 2017. Of course, this was an academic conference, although it was well received. We didn't get very much, feedback from industry. It wasn't until later that year where we had one of the VPs at Amazon visit Carnegie Mellon University, and I believe that they spoke in, one of Andy's database classes. And so what happened is that Andy went up, and was thanking them for providing us with so many cloud credits, because I went through a ton of cloud credits running all of the experiments at the university. So it was a big deal for us, and they gave us several $1,000s worth of credits. And at that point, they invited us to write a guest blog post on AWS's machine learning blog. So we went forward and we published this guest blog post, and then a number of people of industry just came out of the woodworks. There was a lot of interest in the product. People really wanted to try OtterTune. Now, at the time, they were contacting Andy, trying to see if they could get somebody to come out and set up this academic prototype at their company. Which there was only one of me, and we also had a few other research students working with us at the time. But as you can imagine, that doesn't scale, and so we did do a POC with Société Générale, and we published that work in 2021. We had some really positive results there. And then we had also started a POC with Booking.com at that point, also had very positive results. And at that point, we decided that it made sense to spin out this academic research project into a commercial product. So we founded the company in June 2020, and that's when the company started. But that's sort of the background of how we got here.
That's great. I mean, so listeners, I'm sure, are drawing a parallel here because, of course, Tamr was founded out of an academic research project at MIT, Dr. Stonebreaker, with a set of PhD students, thinking through some of the original machine learning behind Tamr's today commercial offering. OtterTune sounds like a very similar experience coming out of Carnegie Mellon. Really interesting academic research, specifically, and also in parallel here with machine learning, then commercializing that. But maybe if you could share a little bit of your experience of kind of these different worlds, the worlds of academia and the worlds of commercial a startup, and what it's meant and how it's been to found a company within an academic institution with a very much an academic bent, and then what it means to then take that and bring it to become a commercial business.
Absolutely. So I will say that the transition from academia to a commercial product, doing a startup, has been really interesting. There are a lot of assumptions that we made in academia that didn't hold up in the real world, as you might imagine. I can give a few examples. So one of the main things that we realized, because we had previously, as I mentioned, done POCs with Booking.com and Société Générale. Now, these are very, large companies. What we're actually able to do is, deploy OtterTune on a copy of the database and, replay the workload. That was what we did at Société Générale. And at Booking.com, they had a staging environment that was very similar to their production environment, which is where we deployed OtterTune. So we kind of made this assumption that all companies had this, and that was not the case at all. Société Générale was running Oracle. OtterTune, the commercial product, we only run on AWS RDS databases, so that includes Aurora and Aurora Serverless, and for MySQL and Postgres. So for MySQL and Postgres, you just they're not commercial databases, so you don't have the set of tools to be able to copy make a copy of the database, and then also the bigger pieces like replaying the workload accurately. On top of that, being able to spin up similar instance, there's a lot of costs associated with this, and it becomes very expensive. And the other lesson there was that we have learned that most customers do not have dev or staging environments that look anything like their production environments. So we tried that initially. What we did is, we deployed OtterTune on a customer. At that time, they were on Aurora. They wanted to reduce costs by reducing IOPS. So that's what we optimized for the configuration tuning piece. And we were able to get a 15% improvement in cost, so 50% reduction. So we took the same configuration and we applied it to the production database, and we saw about a 2% improvement. So these were, this was a big realization for us. So interestingly, what we've done with OtterTune, we transitioned it to a self-service product, And, the other thing that we did is a lot of our customers are running on their production databases. What this means is that just as I'm sure we'll get into OtterTune more, but for some background, OtterTune can automatically apply changes on the behalf of the user to sort of close the optimization loop. So what this means is that we have to be really, really, really careful about the optimizations that we're applying. So we built a bunch of safeguards. That's an example of one of our bigger lessons learned.
Yeah, and this idea that what works in the ivory tower of academia, then when it hits the real world, is maybe some of these assumptions we made or test cases that we had are very different. I think probably resonate with anyone who's worked on an academic project.
Absolutely. In academia too, we were very guilty of, making these assumptions. In the same vein, I understand, both perspectives. In academia, it's very hard to get access to real world data, or anybody's database for that matter. So that's where sort of the mismatch is.
Yeah, 100%. So let's talk a little bit about OtterTune. So you're the chief technology officer. Maybe share a little bit about the technology behind OtterTune. And just to say it, it seems quite counterintuitive that that there should even be a problem here, in the sense that a database is a database. Sure, there are a bunch of settings, but this is why we have database experts in the world. And then if you're me, of course, you just hit all the defaults and it's going to be perfect. Everything will be wonderful. Clearly, I'm wrong, but maybe share a little bit about both the problem and a little bit about how you come to the solution.
Absolutely. So database tuning has typically been sort of the solutions for that have been very manual. So as you mentioned, what you would traditionally do is hire a database administrator or a team of them to manage your databases, and that includes performance optimization. The problem these days is that there's more than two high-level problems overall, but two high-level problems, which is that there's these days companies have many databases, and so the tuning that a human can do is very reactive in that sense. They're not proactively able to keep the databases optimized. When there's a performance issue, they go in and fix it, and that's the tuning. The other issue is just the complexity of databases has continued to grow. For example, back in the early or mid, 2010, like Postgres and MySQL both had, I believe less than 100 configuration knobs. That's still a lot, but, these days they're in the hundreds. So to actually understand all of those knobs and how to configure them correctly for different workloads and hardware becomes a very challenging problem, even for experts. There's just not enough experts in the world with that knowledge. And these days, another thing is that we're seeing a lot of people are with managed, in cloud database services like RDS, Azure, et cetera. They're moving away from having like a dedicated DBA or team of DBAs to DevOps, and or having an engineer in general manage the database. So we find, speaking with a lot of our customers, that the person managing the database, is the poor person that just happened to know the most about, Postgres, for example, and kind of got stuck with the job. So that's sort of the challenge. So the solution we propose is, is doing automatic configuration tuning using machine learning. We've also used our knowledge to kind of come up with an initial recommended set of knobs for people to tune based on what we see being most effective for different workloads. So that's sort of the solution that we propose in the configuration tuning space. So
this might be a silly question, but why machine learning in this context? Wouldn't a set of rules be as effective? And to be clear, clearly they're not. But and I'm in my mind, drawing a bit of an analogy to Tamr, in that we think about using machine learning because we want to be able to learn from prior examples, and there's this strong sort of benefit to prior history in terms of doing, in our case, entity resolution. And it largely would be a manual human task. And as we always like to joke, the problem with people is they like to eat and sleep. And so, and I see some of those parallels in what you were describing, where even if you could find the DBAs, and it sounds like they're hard to find, they only go to where the problem is. They don't work 24/7 across thousands of databases. That's not physically possible. And you're not going to hire hundreds of them that would be necessary to do that. But talk a little bit about the use of machine learning in this context.
Right. So machine learning database tuning is configuration tuning is a perfect is perfectly paired with machine learning. Basically, there's, like I mentioned, there's so many configuration knobs to tune, and what we find is that the right configuration really varies with the workload. Especially, you can kind of come up with some rules for the hardware, but to come up with rules for all of these different configuration knobs for the different workloads that we see at the company is really impossible. There are popular open source products like PGTune, for example, is a popular configuration tuning solution for Postgres. You basically just input the hardware characteristics of the system. So it'd be like the number of CPUs, the memory, storage size, and a few other settings, and then it spits out a configuration just based on the hardware. So while that's a good starting point, we see, I believe, improvements of anywhere from 10 to 30% in the experiments that we run over PGTune. And this is just because the amount that one workload varies from one to the next is just huge. So at a high level for the algorithm, we use Bayesian optimization, which is it's sort of a black box optimization algorithm. In this way, we do need to provide it with some inputs, for example, like the range of knob values to look in, a little bit of information about the type, the data type of the knobs. But over time, there's this feedback loop where we basically we're looking at the metrics from the database system. And that includes performance metrics, whatever the user wants to optimize for, like latency or throughput. And by observing, observing how different knob configurations impact the system, over time, the models converge on a good configuration for the user. And this has proven much more effective in our research.
And probably much more cost effective, because you're not having to have a human being sit there and do their best guess.
That's right. Yes, absolutely.
So you've talked a lot about this in the context of the configuration of the database, but there's a lot more to database performance than the underlying hardware and configuration. How does OtterTune think about the broader set of ways you can make a database work better?
Great question, Anthony. So like I mentioned, the academic version of OtterTune was only focused on configuration tuning. But that was another realization when we got into the real world, is ultimately if you have really poorly written queries or are missing, key indexes, there's only so much you can do with configuration tuning. So in the past, about year and a half, we've been working on expanding the service to provide sort of a more holistic database optimization solution. So now we also provide recommendations with respect to indexes, queries, and resource utilization. So we just released our query recommendation piece, which is exciting. That's more of a data-driven solution in that it basically does anti-pattern matching with SQL queries. But so far, it's quite helpful. And then on the index side, we've released recommendations for identifying unused indexes and also redundant indexes. So these would be, if you have two essentially identical indexes, we can highlight those. So although these aren't machine learning backed like the configuration tuning piece, they have helped customers, identify a number of problems, and improve database efficiency. And we're currently working on, an initial version of recommending indexes that you're recommending missing indexes, which we're hoping to release later this year.
Yeah, I was going to ask about that. I mean, so to that point, so first of all, that's super exciting. This idea that it's, to your point, it's more than just the knobs. There's a lot to a database. From a roadmap perspective, and again, given your role leading the CTO office and the technology, how do you think about where OtterTune goes from here, and from a roadmap perspective, and how do we think about the future of database management? What's it going to look like in 5 or 10 years?
So I guess, the initial roadmap, of course, or the sort of short to midterm roadmap is to continue to improve improve and expand our current database optimization offerings. So like I said, we would like to release a product around missing indexes. Now, this is a really hard problem. There's been research on database tuning since the 1980s, and index tuning is a very hard problem. Microsoft has released like an index tuning tool. It's probably the most state of the art, I guess, commercially available, in my opinion, that I know of at least. And so it's a very hard problem. We're going to solve the problem piecewise, start very simple, but ultimately, like we definitely want to provide, or expand and provide holistic tuning for all of the services. In addition to that, I mentioned the ability to complete the feedback loop with configuration tuning. So one of the reasons that we chose to only provide our offering on AWS, the cloud service, is because it standardizes a lot of the APIs we use. Now, prospective customers come to us, they're running on-prem. The problem with on-prem databases is everybody has their own custom setups. So it's really hard to, we would have to write connectors for each individual customers, and that's just not practical for us. So this is, why we focus on cloud databases. But getting back to the point is that the problem with completing the loop with, missing or, adding or removing indexes or rewriting queries is that a lot of times this needs to be done in the application code. So, for example, like a lot of our customers use ORMs like Django, Ruby. So if you drop if you drop an index through PSQL or whatever command prompt for the database, it will just add it back next time you do a migration if you don't actually update the application code. So this is the major reason like why we can't complete the loop right now for that. So in the future, I think it would be really cool to do, a GitLab integration where we actually do some analysis of the application code as well. And so we would be able to look at, we'd be able to detect when you make changes to the database and even sort of connect that to improvements or degradations in performance. I would love to see like a full-fledged integration where we're able to do optimization at both the database and the application level.
So I am by law required on every podcast to ask about ChatGPT. It's the new rule. But the point you're making there about connecting to database performance to application application code strikes me as a great example of really where large language models and generative transformer models could be quite interesting. I'm sure you have a thought and perspective here.
Yes, absolutely. And in fact, one of our engineers who's leaving to do their PhD at Columbia soon has been working on this exact problem. So, you can go so far as to rewrite queries. He actually gave a talk on this recently at a Postgres conference where he showed a few examples to see if these large language models can go in and rewrite some of our Django code actually to see if we could find some problems. And the results were okay. At this point, I believe the finding was that you really had to prompt it multiple times and feed it, feed the code in multiple times and provide it with hints and be very specific to get any solution. But as they continue to, improve these large language models, this will absolutely become possible. And so this is the direction that they're working in because, of course, you're right, like being able to just fix the SQL, there's actually quite a bit of work. And I've been seeing a number of companies providing this at present, but I don't believe that they can rewrite the application code yet. But that is certainly an interesting research direction.
Yeah, first we get rid of the database administrators, and eventually we'll get rid of all of the developers all the way up the stack, and we'll just be able to hang out at the beach, and our databases will work, and our applications will hum.
Yes, absolutely.
A glorious future.
Hopefully not for my sake, but yes.
Well, by that point, you'll be happy to be on the beach. Hey, Dana, it's been a thrill to have you here, and appreciate you sharing the OtterTune story. Really fascinating to see this academic research out of Carnegie Mellon really, flourishing and helping to contribute to better database performance for everyone.
Great. Yeah, Anthony, thank you again so much for having me. It's great being here today and talking about OtterTune, of course.
Data Masters is brought to you by Tamr, the leader in data products. Visit tamr.com to learn how Tamr helps data teams quickly improve the quality and accuracy of their customer and company data. Be sure to click subscribe so you don't miss any future episodes. On behalf of the team here at Tamr, thanks for listening.